welcome back to Catalystic Chemistry classes. This is an online learning platform. In this class, we are providing coaching for CSIR-NET GATE PGTRB and Polytechnic TRB exam. Okay, so in this classes la நம்ம என்ன டிஸ்கஸ் பண்ண போறோம் அப்படினா மெட்டலோசின் காம்பவுண்ட் இத பத்தி தான் நம்ம டிஸ்கஸ் பண்ண போறோம். ஓகேவா? Actually வந்து we are going to discuss about one of the previous question and இந்த क्वेश्चंसக்கான சொல்யூஷனை இந்த கான்செப்ட் பேஸ் பண்ணி டிஸ்கஸ் பண்ணிட்டு நெக்ஸ்ட் அதுக்கான சொல்யூஷனை நம்ம பார்க்க போறோம். Okay, so the given question is, and this question from CSIR-NET June 2020. The question see here, the question is the correct electronic configuration of frontier molecular orbital of manganese compound is. Okay, so see here in this question they will ask the correct electronic configuration அப்படினு கேட்டிருக்காங்க. So இப்போ இந்த क्वेश्चनக்கான சொல்யூஷன் எப்படின்னு நம்ம பார்க்கலாம். So before that we are going to start this discuss about what is metallocenes and அதுல இருந்து என்ன type of questions எல்லாம் நம்ம எக்ஸ்ப்ளோர் பண்ணலாம் அப்படின்றது தான் நம்ம டிஸ்கஸ் பண்ணலாம். Okay, so if you like my classes, please like, share and subscribe to Catalystic Chemistry. Okay, so see here metallocene. So metallocenes la pathina appadina we can expect the four different type of question. So first one they will ask the electronic configuration. This electronic configuration it is based on the frontier molecular orbital diagram. Next second one pathina it is magnetic nature, either it's a paramagnetic compound or it may be a diamagnetic compound. Next magnetic moment, what is the magnetic moment? That is Bohr magneton value. Next that is bond order, or it may be a bond length, or it will bond stability. Okay, so bond order calculate பண்ணீங்க அப்படினா you can easily identify MC. Okay, metal to carbon bond length in the metallocene compounds and bond stability. We know very well bond order and bond stability both are directly proportional. Bond order is increasing, stability also increasing, bond length will be decreasing. So இந்த மாதிரியான क्वेश्चंस உங்களுக்கு இந்த யூனிட்ல இருந்து கேட்டிருப்பாங்க. Okay, so see here first metallocene அப்படிங்கற general formula எப்படி இருக்கும் அப்படினா this MCP2. Okay, MCP twice இருக்கும். CP is nothing but cyclopentadienyl group. Okay, so there are two group and it is attached with the transition metal. Okay, so see here it is look like that cyclopentadienyl group. Okay, either it may be a staggered metal and the metal it belongs to the transition series. Okay, next. Okay, so it is a sandwich compound அப்படினு சொல்லுவாங்க. Okay, so metallocene compound it also known as a sandwich compound. So அதாவது பாத்தீங்க அப்படினா it is these two rings are present in the parallelly, in between these two rings it is present in the transition metal is present. Okay வா? So இப்போ இந்த மாதிரியான காம்பவுண்ட் எப்படி இந்த மாதிரியான क्वेश्चंஸ்க்குலாம் ஆன்சர்ஸ் ஐடென்டிஃபை பண்றது அப்படின்றத டிஸ்கஸ் பண்ணலாம். Okay, first இந்த metallocene compounds ஓட frontier molecular orbital diagram எப்படி இருக்கும் அப்படினு பார்க்கலாம். So actually வந்து பார்த்தா இது ஒரு long diagram வரும். For our convenience இந்த क्वेश्चனை சால்வ் பண்றதுக்கு பதிலா ஷார்ட்கட் எப்படி ஞாபகம் வச்சுக்கணும் பாத்துக்கோங்க. See here first we know very well it is a d orbital. Okay, d orbital it is split into three different energy levels. Okay, it is split into three different energy levels. Okay, so first one it is பாத்தீங்க அப்படினா it is d x squared minus y squared d xy, and this is dz squared orbital, and this one dxz dyz. Okay, so usually வந்து பாத்தீங்க அப்படினா நம்மளோட d orbital வந்து பாத்தீங்கன்னா it is split into two different energy level, one is T2g and another one is Eg அப்படினு split ஆகும். But here in this case of metallocene the d orbital it is split like this, இந்த மாதிரி three different energy level வந்து split ஆகும். So இதோட molecular terms usually they will ask some molecular terms தான் கேட்பாங்க. So see here இந்த state ஓட molecular term அப்படினா it is E1g, this one is A1g and this one is E2g. Okay, so this is the molecular terms. Next in the ரெண்டு levels பாத்தீங்க அப்படினா it is a bonding molecular orbital. Actually சொல்றோம் அப்படினா this one is bonding orbital. Okay, there is a bonding molecular orbital, this is non bonding molecular orbital. Next this one it is anti bonding molecular orbitals. Okay, so in the மூணு நமக்கு கண்டிப்பா தெரியும். So this is the splitting diagram. Okay, or frontier molecular orbital diagram of metallocene compounds. Okay, so இப்போ இதுல தான் நம்ம electrons fill up பண்ண போறோம். This energy level will be differ from the molecules to molecule. ஒவ்வொரு காம்பவுண்டுக்கும் இந்த energy gap வந்து differ ஆகும். For example, if I am going to take a vanadium, okay, vanadium Cp twice and chromium Cp twice, manganese Cp twice. So these are some examples for different metallocene compounds. Okay, so manganese one compound, next iron Cp twice, next cobalt Cp twice. Okay, so in the different compounds எடுத்துர்க்கேன். So I am going to make this two different type of compounds. Up to manganosine, okay, these are formed the high spin complexes. Up to manganosine, high spin complex. What do you mean by high spin complex? Abhina? See here, the energy difference between these two orbitals. Okay, so see here, இதோட diagram எப்படி இருக்கும் அப்படின்னா, it is equal. Okay, the energy difference between these all the energy state, it is equal. Okay, everyone is equal. So the fourth electron is automatically 1 2 3 and fourth electron வந்து இங்க automatically fill ஆயிடும். Okay, then அதே மாதிரி தான் manganese compounds 1 2 3 4 and 5 they have a equal distance. But அதே வந்து after this ion அப்புறம் வரும்போது பாத்தீங்க அப்படின்னா the energy difference between bonding and anti-bonding energy level is very high. So they can form the high spin complex usually. They can form the high spin complex. So see here they have a energy difference between these two levels. So அப்ப என்ன அப்படினா fourth electron it again fill in the lower energy state. Okay, it can form the low spin complex. Like the same here also it can form the low spin complex. So up to manganosine they can form the high spin complex. After that they can form the low spin complex. The most stable or the most strongest metallocene is a ferrocene. Okay, ferrocene is the most strongest, most stable metallocene. Why? Because it follows the 18 electron rule. Why? Because its valence electron of ion is 8 plus contribution of Cp it is 10. So totally it is 18. So it obey 18 electron rule and this is the most stable one. And one of the exception is manganosine. We will discuss what is the exception of manganosine. நம்மளோட இன்னைக்கு கேட்ட the questions வந்து பாத்தீங்க அப்படினா it is also exception case of manganese based பண்ணி தான் இந்த questions கேட்டிருக்காங்க. இந்த metallocene compound ஒரு example வச்சு நம்ம டிஸ்கஸ் பண்ணலாம். அந்த 4 different questions க்கு எப்படி answers identify பண்றது அப்படினு பார்க்கலாம். Okay, so see here I am going to take an example vanadium Cp twice. Okay, so இந்த compound தான் நான் எடுத்துக்கிறேன். So first we should identify the oxidation state of vanadium. So we know very well Cp its charges -1, so it is the oxidation status X plus. There are two Cp ligands, so -2. Overall charge is 0. So X equal to it is a +2. Here vanadium in the +2 oxidation state. So scandium, titanium, vanadium. So its electronic configuration is argon 3d3 and 4s2. So this is the electronic configuration. When vanadium in the +2 oxidation state, we have to remove 2 electron from here. So the electronic configuration is argon 3d3 and 4s0. So d orbital it contains a 3 electron. So I am going to take this MO in the diagram எடுத்துக்கிறேன். So see here I am going to fill the electrons 1 2 3. It is a d3 configuration. So we are going to fill the electrons here 3 electrons. Now first start the electrons from the bonding molecular orbital. Why? Because it is in the lowest energy level. Okay, so 1 2 3. Okay, so these all are in the same equal energy level. Okay, they are in the same energy level இருக்கிறதுனால தான் electrons வந்து இப்படி fill ஆகுது. So 1 2 3 இப்படி fill ஆயிருக்கு. ஓகேவா? So what is the electronic configuration அப்படினு கேட்டாங்க அப்படினா see here take a look at the symbol. So E2G, how many electrons? We have 2 electrons. A1G we have only 1 electron and it is E1G there is no electron. So this is the electronic configuration based on frontier molecular orbital diagram. Okay, they will ask like this only. So E2G2 then A1G1 E1G0. So this is the electronic configuration. Next it is a paramagnetic or diamagnetic, that is magnetic nature. So see here there are 3 unpaired electrons are present here. So it is a due to the presence of 3 unpaired electron it is a paramagnetic in nature. The compound is paramagnetic in nature. Next, what is the magnetic moment value? So it is nothing but spin only magnetic moment calculation, root of n into n plus 2 bm. Okay, so according to our shortcut how many unpaired electrons are present? There are 3 unpaired electrons are present. So if it is a 3 unpaired electron அப்படினா இது ஆல்ரெடி நம்ம வந்து coordination chemistry ல பார்த்திருக்கோம். So if it is a 3 unpaired electron means it is a 3.87 bm Bohr magneton. Okay, next the last question number 4, it is bond order. Okay, bond order based on this relation we can identify the different questions kana answers identify பண்ண முடியும். So first bond order. So bond order is equal to what is the formula? It is already everything. Number of electron in the bonding molecular orbital, number of electron in the anti-bonding molecular orbital divided by 2. So this is a formula. So in this case, see here we know it's a bonding molecular orbital, it is non-bonding and this is an anti-bonding. Okay, but when you are writing this and non-bonding, it is also included in the bonding molecular orbital. So how many electrons here? 1, 2, 3. There are 3 electrons in the bonding molecular orbital. Next, anti-bonding molecular orbital, there is no electron. It is divided by 2. So 3 by 2, so we get 1.5. Okay, so the bond order is 1.5. So like this, we have to work out the question. Okay, so one more example. The second example is magnesium Cp. Okay, so in the complex corner, in the 4 question answers we will discuss. First, we are going to draw the frontier molecular orbital diagram. Okay, so 1, 2, 3, 4, 5. D orbital. It's split into 3 different energy level. So 1, 2, it is 3, 4, and 5. Okay, so we know very well it is E1G, A1G, and this one is E2G. Okay, in manganese it is also in here it is a +2 oxidation state. It is a D5 is the electronic configuration. So 1, 2, 3, 4, 5. So in the fill up it is the lowest energy level 1, 2, 3. The fourth electron is fill in the higher energy level 4 and 5. So it forms the high spin complex. Okay. Now what is the electronic configuration? So see here it is E2G 2 electrons, A1G only 1 electron, and E1G it is 2 electron it is present. Okay. Next, second question is it is a high spin complex. Why? Because the fourth electron is fill up in the higher energy state, so it is a high spin. Okay, it is high spin complex of follow. Next, third question, it is nature, magnetic nature. All are paramagnetic. Why? Because unpaired electrons are present, so it is a paramagnetic. Okay, paramagnetic in nature. Next one, fourth question. Okay, magnetic moment. There are 5 unpaired electrons are present. According to our shortcut, 5 unpaired electrons is a 5.90 or 92 m. Okay. Next, fifth question. It is bond order. Okay. So bond order calculation here. So bond order equal to number of bonding electron minus number of anti-bonding electron divided by 2. So how many electrons here? Bonding like totally these are bonding cancel pannalam. So 3 minus it is 2 divided by 2. Okay, so we get 1 by 2, it is equal to 0.5. Okay, so the bond order is equal to 0.5. Okay, so based on this, we can calculate the relation. Sometimes, CS students, in the CP badla, they will mention it is a CP star. Okay, CP star, it is nothing but it is a substituted cyclopentadiene. Usually, say a cyclopentadiene brother. Okay. So usually it will come. Okay, we know very well it is a cyclopentadiene ligand. Okay. Now CP star question paper mention this 5 hydrogens are replaced by the methyl group and it is look like CH3, CH3 and CH3, CH3. Okay, it is substituted. Now in this case it acts as a strong field complex. Okay, it is act as a strong field complex. So the energy gap between bonding and anti-bonding molecular orbital will be increases. So high spin low spin so the electronic configuration will be differ. Magnetic moment also differ. Magnetic nature differ chances. Next bond order definitely will be differ. Okay, this will change. So while you are solving the question, please take care of this molecule. Okay, in the star it is act as a strong field ligand. Okay, otherwise it is formed the weak field ligand only. Next example, that is nothing but ferrocene. Okay, Fe, it is Cp twice. Okay, it is a ferrocene. We know very well ferrocene it follows a 18 electron rule. Okay, it is the most stable one. Here iron oxidation state also it is the +2 oxidation state. So the electronic configuration is argon 3d6 and 4s0. Okay, so it's a frontier molecular diagram see here 4 and 5. Next, it has the energy difference is maximum energy difference. Okay, so it is E1G, A1G, then it is E2G. Okay, now how many electrons? There are 6 electrons are present here. So 1, 2, 3, 4, 5, 6. Okay, 6 electrons. Now we are going to fill in 1, 2, 3. And fourth electron again it is coming to the lower energy state. Why? Because the energy gap is maximum. Okay, so above the fourth electron it will fill up in the lower energy state only. So 4, 5 and 6. Okay, and there is no electron here. Once it is complete another kapra higher energy state ku po. Okay, so now the first question, the electronic configuration pathinga appadina it is E2G4, then A1G it is 2 and E1G it is 0. So this is the first question. And next question, it is a high spin complex or low spin complex? Exactly, it is a low spin complex only. Okay, it is a low spin complex. What is the magnetic nature? So see here, all the electrons are getting paired up here. So there is no unpaired electron. So it is a paramagnetic in nature. Sorry, diamagnetic in nature. Okay, it is diamagnetic nature. Magnetic moment value. So see here, there is no unpaired electron is present. So no unpaired electron means diamagnetic compound the magnetic moment value it becomes 0 BM. Okay, 0. Diamagnetic compound magnetic nature. So magnetic moment irukadhu. Okay, next fifth question, it is bond order. Okay, so bond order formula see here, number of bonding molecular orbital. How many electrons are there? There are 6 electrons are present in the bonding molecular orbital. Minus anti-bonding region lo pathina there is no electron, it is 0 divided by 2. So 6 divided by 2, so 3/2 it is 3. Okay, so appo enna appadina the bond order it is equal to 3. Okay, so that's why ferrocene is highly stable. Why? Because when bond order is maximum, bond stability also maximum. Okay, so see here in the cases of pathinga appadina M and C, the bond distance is very low in the case of ferrocene. That's why this compound is highly stable. Okay, the stability of manganese is very high in the case. Okay, so these are the question. Now previous year like CSR questions varlam. So see here, the question is see here, the correct electronic configuration of frontier molecular orbital diagram of metallocene compound. ஒரு compound கொடுத்திருக்காங்க, it's nothing but substituted manganese compound. நம்ம ஆல்ரெடி டிஸ்கஸ் பண்ணியிருந்தோம், when substituted manganese அதாவது methyl group substituted ஆயிருந்தது அப்படினா the CP ligand it act as a strong field ligand act பண்ண ஆரம்பிக்கும் இந்த இடத்துல, then it can form the low spin complex. Okay, so இந்த क्वेश्चंस சால்வ் பண்ணிட்டு உங்களோட ஆன்சர்ஸ் என்ன அப்படிங்கறத கமெண்ட் செக்ஷன்ல லீவ் பண்ணுங்க. ஆன்சர் A B C அப்படிங்கறத சொல்லுங்க. Okay, so if you like my classes please like, share and subscribe to Catalystic Chemistry. Thank you so much students.